Hello everyone, welcome to the second lecture of the SQL subqueries where we are going to discuss not only correlated SQL subqueries, also the joining available in the SQL language. So we have learned about the non-correlated subqueries in the part 1 of the lecture. In this part, we are going to start with correlated subqueries. Correlated subquery is those subqueries where the inner query generates a result on the depending on the outer query. And how it depends on the outer query? Depending on the condition, values of attribute of each and every tuple of the relation present in the inner query will be matched with the value of attribute of each and every tuple of the relation present in the outer query. After that matching, those tuples which are selected will be my result for the inner query. Now, so better understanding this one, let us take some examples of the correlated subqueries. For this, we are going to use the employee table as the previous. So we have already discussed what is that employee table and what are the contents of this. And we are going to use the department table same as the previous videos available in the previous video. So the first example is display the name of the employee who earn highest salary in their respective job. So how we are going to solve this? In the first part, in the inner query part, we are going to find the maximum salary of each job. Now how can I do that? By using the max salary function where we are grouping grouping them with respect to the job, and that will come from the employee table. Then we are going to select the maximum salary where the job, that is group job, is matching with the job of the employee available in the outer query relation. So for understanding that one, let us take an example. These two relation. Here we are selecting, for our simplicity, we are selecting the employee name, salary and job from the employee table. And here what we are doing, we are selecting job and maximum salary, and we are grouping them by job. So this is my part of the inner query. Then in the inner query, not only that, what we are doing, we are checking that for each and every tuple present in the outer query, we are checking that their job is matching with the job over here or not. So this P will be checked with this one, then with this one, then with this one, and as there is a matching, then this value will be selected. Then it will check for this one, as this is not matching, so it will not be checked. Now for the second row in the outer query, the job is M, so the M will be matched with this one. So that time this will be selected, and it will check with rest of the data, and as there is no matching, no more will be selected. Similarly for this all the four rows will be matched, or all the four attribute value for the job will be matched. Similarly, now let us take for S. First this one will be checked, then this one, then this one, then this one, and there is a match, so this one will be checked. This one will be selected, and this will continue for all the 11 rows available in this query. Now what is happening now? After that, what will happen? Let us take the Smith. His job is P. So which salary will be selected? Which maximum salary will be selected? This maximum salary will be selected. Then we are going to check this maximum salary is equals to Smith's salary or not. As this is equal, then we are going to show the name of the Smith. Now for Alan, his job is M, so we are selecting, we are checking with M, and as it is same, so this salary will be selected. Now we are going to check this salary with the salary of Alan or not. Alan with Alan is same or not. As this is not same, then Alan names will not be selected. But in case of Sammy, his job is M, so M and M will match. So this salary will be selected and Sammy's salary is this one. So they are exact matching. So Sammy's name will be shown. In this way, the outer query will affect the inner query. The final query is select employee name from E, that is the we are analyzing the employee table with E, where salary equals to select maximum salary of F. F is the another alias for the employee in the inner query. From employee F, group by F dot job, we are grouping by job, having F dot job is equals to E dot job. This E dot job is actually E is from coming from the outer query. So this represent the job of the outer query, and F is the aliasing of the employee for the inner query. So this represent the job group job of the inner query. So we are getting Smith, Sammy, Blake, and John, and let us verify with that. So for S, the maximum salary is 45,000. Blake is getting that one. So Blake's name is shown. And P is Smith. Sammy we have already discussed. And for the worker, it is 29,755, which is John. So we are getting the expected output. Now let us discuss another problem with the correlated subquery. So for the second example of correlated subqueries, we are going to use the department 1 table, which is similar to the department table, but here there are 9 tuples storing the information of the departments. Now the problem statement goes like this: show the location where all the departments are available. Now here we need to focus on the term all the departments. When the query is dependent on the all value of a particular attribute, you need to understand this will be the similar to the division operation of relational algebra. Now this query we are going to perform the division operation of relational algebra using SQL. Now what does the division operation do? Suppose we are storing the department name and we are considering the department name and the LOC. So what are the different LOCs are available? The different LOCs available is Kolkata, Mumbai, Chennai, and Delhi. Right? Now if I ask, show me the department which is, if I ask you to write a relational algebra query where I says you that show the department which is available in all the locations, then we are going to perform a relation which is on D name and location, and we are going to divide that relation by another relation which is on location, storing the all the locations available. So this will give me the departments which are available in all the locations. Now my query is we need to show all the locations which have all the departments. So my relation will be obviously of location and dname, and we are going to divide that with another relation where all the dnames are available. So we are going to implement this relational algebra operation using the query. Here we are going to use the correlated subquery, and remember only correlated subquery can solve this kind of problem. So what is that logic here? First consider the location and the dname. Next we are going to use the inner query. The inner query, there will be two different queries. First part of the inner query will give me all the different departments. The different departments available are operation, finance, sales, and production. So this is all the different departments available. Let us consider this as a A. Then in the next part of the inner query, what we are going to do, there we are going to use the concept of correlated subquery. We are going to use the relation of the outer query, which is department 1, and from department 1 we are going to take each and every row, and we are going to check where the location of the outer query tuple is matching with the location of the inner query tuple. If there is a match, then we are going to take the department name in the inner query. So let us take the inner query part is the second inner query will give me a relation B. So first we are going to get the outer relation will give me the location KOL. Now in the inner query, what we are going to do, we are going to check this KOL with all the values, all the location values, and where there is a match, we are going to take the department name. So I will get O for this tuple. I will get F for this. I will get S for this, and I will get P for this. Now, then we are going to subtract A minus B, a set difference A minus B. So we know that A minus B in set difference means that the value present in A but not in B. Now, in this case, we are going to get a null. When we are going to get a null for this inner query, means the inner query is returning no tuples, then we are going to say that for that location all the departments are available. Now let us take, so for Kolkata, this first tuple will give me KOL. Then for the next tuple, what I am having? I am having MUM as the location. So the A will not change, but the B will give me the departments which are available in Mumbai, and this will give me finance and production. So A minus B in this case will not be null. As it is not null, we can say that the Mumbai does not have all the departments. Similarly, for the third tuple, the location is CHE, and A will not change, but B I will get production, then I will get sales, and nothing else. So A minus B is not null. So we can say that the Chennai is not the location where all the departments are available. Now for the fourth tuple, we are getting DEL. So in DEL there is sales. So S will be there in B, and there is no other department in B in Delhi. So A minus B is not null. So Delhi will not be there. So similarly, it will continue for all the rest of the tuples also. And finally, we will get that only KOL is the location where all the departments are available. Now the question arises, how we are going to check that the inner query is returning a null relation, means a empty relation, or some tuples. Now that can be done using the clause exist or not exist. Now exist and not exist are the clauses where we are going to use when we going to check that the inner query is returning any value or not. What value it is returning, that is not my concern, but the concern is it returning any value or not. If we are going to use the exist clause, then if the inner query is returning any value or giving any tuple, then the exist will give me true, else it will give me false. So, and for not exist, if the inner query is not giving any tuples or not giving a null, then it will give me a true value, otherwise it will give me a false. So in this case, as for KOL, the not exist will be true, then that department name and the location for that particular tuple will be shown in your as the output. Let us run this query and see what the output we are getting. Now next, this is all about the correlated subquery. Remember, division operation of a relational algebra. If you implement in SQL, you have to use correlated subqueries. Now for the next set of problems, we are going to use the concept of joining, and for better understanding of the joining, we are going to use the similar employee table at the same department table what we have already discussed. So in SQL, there are different types of joining available. There is cross join, there is inner join, or you can say it is equi-join. Then you have natural join, and there are outer join, which can be of three types: left outer join, right outer join, and full outer join. Their concept is similar to the relational algebra joining, and we are going to implement them. We are going to see how it can be implemented in SQL. So let us discuss the cross join. It combines each row of the left relation with each row of the right relation, right? And how we can perform that one? This cross join is basically the Cartesian product or the cross product of the two relations. So here we can use either this notation, select star from employee comma department. Here we are going to cross join employee with the department. So each row of the employee will be combined with each row of the department. And as in our example, there are 11 rows in the employee table and 8 rows in the department table. It is going to produce total 88 rows, and as per the Cartesian product rule, it is going to give me 10 numbers of attribute. As in employee there are 7 attributes, and in department there are 3 attributes. 7 plus 3, it is 10 attributes will be produced. Or you can, our other notation is select from employee cross join department, right? You can use any of the notation for solving this problem. So let us run that one and see what output we are getting. So you can see that there are 88 rows, and if you count carefully, you will find there are 7 plus 3, 10 attributes are there. The next type of joining is the inner join or equi-join. It combines some row of one relation with some rows of the other relation depending on the joining condition. So there will be a condition, as it is, we are saying it as a equi-join, then the condition will be is of equals to type. So you can use, there are two different notations for that. The first one is this part is similar to cross join, and here we are giving a condition which is a equality condition. This dpt number and dp number is the connecting attribute. So their data type and they are connecting, there is the connecting attribute. So using this attribute or checking the equality of these two attributes, we are going to select some of the rows of the 88 rows we are produced in the cross join. Similarly, the other notation is select star from employee E. Here we are using the term inner join. Instead of inner join, you can write join also. The employee E will be joined with the department table. Department table is aliased with D. Then we are going to use the on clause, and after that on clause we are going to produce or going to give the condition on which the joining will be performed. So let us run both of the queries and we are going to get the same result. You can get that the condition was DPT number will be equals to DP number. You can see here. Now we can see that we are selecting only those rows where the DPT number is equals to DP number. So we are going to get these 11 rows. Now let us run the other notation of the inner join or equijoin. So you can see that we are getting the rows where the DPT number is equals to DP number. Now let us take the other type of join, that is the natural join. Here it combines some of the rows of one relation with some of the rows of other relation where the value of all common attributes of the relations are matching. Now what is this? Let us take the employee table and the department table. Here you can see that there is no common attribute, no attribute having the same name. In this case, the natural join in case of SQL, it is going to produce a result similar to the cross join. Now, if there is any attribute common between the two relations, it will directly perform the equality as inner join or equijoin and produce the result which are where the common attribute values are same. Now if as there is in this case there is no common attribute, so we are going to get a result similar to the cross join. You can see there are 88 rows because there is no common attribute. But what if we are going to change the relation and both of the cases the relation is same? We are performing natural join of department table with the department table. All the attributes are same. So the relation we are going to get or the result we are going to get will be same as the department table. Right? This is the department table. Now let us change that one and see if we perform the same thing with the employee table. What output we are going to get. Here you can see that the first value, that is the value for the Smith, the row for the Smith is not available because in case of manager number, Smith is having a null value. As null cannot be used for equality, so this condition is becoming false in case of natural join where manager number will be checked with the manager number. As that is not true, then that row will not be selected or will not be considered in the final result. So this is how the natural join is going to work in case of SQL language. So that's it for today's video. In the next part of this video, we are going to see some practical uses of the joining in the SQL language with some examples related to our employee and the department table. Till then, stay safe and thank you.